Good morning, everybody, and welcome again to another OpenShift Commons briefing. This time, we're going to be talking about Istio, a wonderful new open source project that's come out of IBM and helping us get the service mesh stuff all squared away for OpenShift and Kubernetes. And we have Chuck again with us, who's going to talk about it and give us an overview and a bit of a demo. You can ask questions in the chat, and we'll have live Q&A at the end, but I'm going to let Chuck get started, and we're going to try and explain everything you need to know about Istio and microservices on OpenShift. So there you go, Chuck. Take it away.
Thanks, Diane. Thanks, everyone, for joining. I'd like to introduce you to microservices on OpenShift and also touch base on some of the service mesh concepts using Istio. So one of the fundamental requirements, if you look at for microservices, is having a platform to provision infrastructure very fast. This is critical for any microservices adoption. And then OpenShift basically provides you with a very good platform for self-service infrastructure and also providing a resilient platform for your microservices. This is my analogy of OpenShift and then the underlying Kubernetes platform. I think of Kubernetes as a kernel for your entire data center. So you no longer worry about individual infrastructure pieces. You just need to have enough capacity. And OpenShift is basically acts like a operating system for your data center. The reason why I call this is Kubernetes gives you that kernel-like features, whereas OpenShift makes it complete for any organization to use it. Right. This is also another analogy I have. What exactly is OpenShift adding on top of Kubernetes? It's basically adding all the missing developer features and then a lot of other tools for making it really enterprise ready. With that, let's take a look into the different options that OpenShift provides on top of Kubernetes to really bring it to enterprises. So with OpenShift, you can containerize your application from literally anywhere. I would say the usual way you do is Docker image. But OpenShift also supports various other methods, maybe using Dockerfile or converting directly from source code to Docker image. This is pretty useful if you want to bring container adoption to entire organization. Because not everyone wants to write Docker files or Docker images. Some people just want to code. So this will really help all kinds of developers adopt containers in your organization. And then also you can also start from WAR files or jar files. This is also pretty common everywhere in organizations. So OpenShift literally takes Kubernetes and really makes it enterprise ready for your microservices adoption. And then next comes the day-to operations of microservices. OpenShift provides a resilient infrastructure, self-service portal, and everything is good. But that is still deploying your applications as microservices. Then what about the day-to operations of microservices? Whether it is distributed tracing, like your application, microservices application needs some kind of tracing, because if you don't have any visibility inside your application, then a lot of things can go wrong. This is based on my personal experience working on a microservices platform for a mobile backend as a service. If you don't have a visibility inside your what's going on inside your microservices, then you are basically introducing a lot of complexity inside your stack. So you need to have some kind of tracing, and then also when services come up and go, they need to discover and then scale across your infrastructure. So a lot of service discovery needs to happen. And then when you have this microservice architecture, we have introduced network into the picture, and then network is easy to fail, and then you need to retry services if they fail. So you need to have some kind of retries mechanism as well, right? And then similarly, you need to have different things like load balancing, secure connection between microservices, all these features that you require for the day-to operations of microservices. Uh, we are currently doing with some kind of libraries. If you look at the Netflix OSS stack, we are using for each of these purpose, we are basically using some kind of library for that. The problem with this approach is you might be using a different technology, let's say Node.js, but you don't have much support for that particular technology. You have to create all these tools on your own. And then most of these things are operation specific, which developers may not be aware of, like how to do them well. And then the application itself gets bloated with a lot of unnecessary non-business related logic inside the application itself. So what if we can take all of these features? What if we can get all of these features without having to write any code? That would be awesome, right? So that's what Istio is all about. Istio is basically a open platform to connect, manage, and secure microservices, but without having to write those huge libraries into your application itself. Okay, how does it work? So let's look at how it works without Istio, and then we can look at how it works with Istio. So without Istio, if a service A wants to call service B, you need to use some kind of library so that you can get that distributed tracing and then load balancing, all these features. So you have to use that library inside your application. Whereas in Istio, you're calling technology or whatever logic that you have that is inside the application will go into a separate layer that is just above the application, and then in between your infrastructure and your application. So this library that you see is platform agnostic or language agnostic. So it can work with Java, it can work with Node.js, or it can work with any kind of technology. So in our case, in Istio's case, this is a Envoy proxy that is developed at Lyft. In some other cases, there are different proxies as well, which does the same job. But in case of Istio, it is done by Envoy proxy. Envoy proxy is a C++ proxy built specially for these microservices, I would say. By far, it has most microservice friendly features as of now. So what I want to show now is basically how to deploy Istio on OpenShift, and then look at a sample application like a book info application that comes along with the Istio docs. I want to show how we can deploy Istio on OpenShift, and then also how do you manage or get all these uh, microservices operation features using simple YAML files. So in our case, the sample application that we have is basically a book info application. You have a bunch of services here. So you need to focus on this. Only then you'll understand the next steps. So try to focus more on this. So we have a product page microservice, which basically acts as a UI. And then that product page will call different bunch of microservices. It calls a reviews microservice, and then it also calls a details microservice, each written in a different language stack. And then reviews will further call rating service. Okay. And the other thing you need to keep in mind is reviews microservice has 3 versions of it. One with no stars, second one with black stars, and then third one with red stars. The reason we are doing this is because we want to explore some of the operational aspects of Istio. So keep that in mind. So you have a bunch of microservices. One microservice is having 3 versions of it. Okay. So with that, let's see how this works when we deploy with Istio. So when we deploy with Istio, it becomes something like this. So you have a ingress which is Envoy, and then you have product page microservices. Along with that product page microservice, you have a Envoy sidecar container which is sitting in the same pod, and then a similar case with all other microservices. So all the communication between these services will happen only through that Envoy proxy. Then this Envoy proxy also sends all kinds of metrics like how many times a call succeeded, how much time it took, like what is the distributed tracing, uh, how can I control the request flow. All these can be done by applying simple configurations at this sidecar proxy. And all the applying of rules will be taken care by the Istio control plane. So you don't need to go for each individual microservice and then apply them. Istio control plane will go and apply these microservice rules into these corresponding sidecar containers. With that, let's go and install Istio on OpenShift and then try this example out. Okay. Just want to confirm, can you see my screen?
No, we can't, not yet. So I'm not seeing your terminal.
Okay.
You're still sharing, but the terminal is not showing. So maybe you have two. There you go.
All right, cool. So I just have a brand new OpenShift cluster on my Mac. So I have my examples listed in this repo. If you want to take a look after the call at this location, okay. So I'm using a automated script, but this is all happening live, okay. So I'm going to set up OpenShift cluster. Sorry, my setup OpenShift cluster is already set up. I'm going to set up Istio now. So for setting up Istio, we need to look into some of the policies. On Kubernetes, this is straightforward. It's almost straightforward on OpenShift also, because OpenShift is somewhat more restricted when compared to Kubernetes in terms of security. We need to add a bunch of SCC policies so that it can work seamlessly. But this is all for the sake of security. Okay. So I'm moving to Istio folder. I have already cloned it. What I'm going to do is install Istio with a single step, that is applying this istio.yaml file. This will create a bunch of RBAC and then also deployments. And then I want to install a few add-ons, which are basically Prometheus, Grafana, and there's a small utility called Service Graph. These are the add-ons that comes along with Istio. That's mainly for collecting metrics and then showing it on the UI. Okay. These are optional. It's up to you if you want to choose have it or not. Okay. So now the Istio control plane should be provisioned. If we go back to our cluster, I'm going to make my user cluster administrator so I can see everything. Now it will create a namespace called Istio system where everything will be deployed. So you can see Istio certificate authority, egress, ingress, and then mixer and pilot. These are basically the Istio control plane services. You don't need to worry about what these individual pieces are, but understand these two are critical ones: the Istio pilot and mixer, which basically takes care of accepting our like the configuration and then applying into the individual microservices. And then the other add-ons tools that we provisioned are Grafana and then Prometheus, and there is a small utility called service graph. We'll dig into each of these. Don't worry about it. Now, what we want to do is, since the Istio control plane is ready, let's go and deploy our microservices application, the book info sample application. So we're going to deploy book info sample application. For this, what we're doing is we are using something called as Istio CTL cube inject. This basically embeds the Istio Envoy proxy into the deployment configuration of our application. That's all, okay? And then we are basically applying as though it is like a simple YAML file. Now, this creates a bunch of services like details, ratings, reviews, and product page, just like we have seen in the initial diagram. So if I go back to my project, then you should see all the corresponding microservices for our sample book info application. Okay. And if you look at this closely, there are two containers running on this deployment. For each microservices that you see, there are two containers running. One is the actual microservice application, and there is another proxy that is running alongside with the um, application container. So these are all in the same part. So all this communication from these microservices will be controlled or sent only via this proxy. That's how you are basically getting all the good information you need. All right. So now that we have deployed the microservice application, let's go and expose our add-ons. We can use either OpenShift router for exposing the services, or you can also use Ingress. It doesn't really matter. I've used OpenShift router in this case. Now, basically, this is a small utility that is provided by Istio to show how your calls are being made. You can see that this is empty now because we haven't made any calls to our application yet. Once we make calls to our application, it automatically generates all the mapping for you. We will see once again after hitting some traffic, then you'll understand more what this is all about. And then also I'm exposing Grafana, which is a dashboard for seeing metrics on a different endpoint. You can see there is nothing here as of now because we haven't accessed any traffic yet. So keep watching. And then we are going to hit the product page now. Give it a couple of seconds. Sometimes it takes a couple of seconds to come up. So this takes a couple of seconds to come up. Once that is ready, we should be able to see the application here. I'm going to check if there are any questions meanwhile. There's a proxy debug container. Is that Envoy? Yes, this is a proxy debug is basically a Envoy container running alongside the application container. Is there a good way to convert existing OpenShift apps to be Istio file? So one of the ways is to use the admission controller that is coming up in Q1.8. That will automatically convert your deployment configurations into Istio specific configurations. Or I have created one special controller, which watches the OpenShift API and then converts the deployments automatically into a Istio specific deployments. Both are possible. In this case, we have used a command line tool, which is cube inject, to convert those things. Okay. Now, so this is demo. Demos are meant to be fragile. Okay. Give it a couple more seconds. Should be okay. I haven't created a route, so that's why I just created a route. and now it should be able to access. So you can see it is the book info page is up. There are two users here. One is normal user, which is like for everybody, and then I can also log in with a specific user ID. Okay. Now, if we take a close look, if I do refreshes on this page, you can see my reviews microservices getting called. Each time I call, it is calling a different version. Sometimes black, sometimes no stars, and sometimes red stars. If we go back to our initial book info application, please uh, pay close attention to this. So this is revision 1, review 2, and review 3, right? And this is further calling to rating service. So as of now, it is like a round robin policy. It is basically choosing a round robin policy to call the reviews microservice. So with Istio, how do we control this traffic? Like, let's say I want to only send it to reviews version 1 only, which doesn't have any stars. Or I want to send it to only a specific user. Let's say a user called Jason should have access to a review service which is having red stars. But for everyone else, I want to show just the normal one, like the no stars or the black stars one. Okay, so all these things that you require for the day-to operations of microservices can be just done by like simple YML files. We'll see some of those things now. Okay. So now that we have hit this endpoint few times, if let's go and take a look into the service graph. Now you can see our service graph automatically got generated. So we have hit the product page, and the product page has called reviews microservices, sometimes version 2, sometimes version 3, and sometimes version 1. And then it also called details, and then reviews further called ratings. So all this service graph that you see got automatically generated. You haven't done any coding at all, right? So this is a very great value add for all the developers. They don't need to worry about all this stuff. This is automatically generated free for you. And then also, if you look at the metrics, now you can see data coming up inside the Istio Grafana dashboard. So you can see the global request volume, and then also the success rate. If there are any failures, those failures will be listed here. If there are any 500 errors, all these things are listed. And all these things, you can also go by service level, like the detail service, how is it performing, the product page, how is it performing, what is the latency. You can see a lot of wealth of information on your microservices without having to write any single line of code. So that is a very great value add that Istio brings on top of OpenShift to make it really easy for the day-to operations of microservices. We'll see more. Let's move on with the request routing part, where I want to control how the request gets flown between your product page to the other microservices. So as of now, there is no control on this. It's basically doing a round robin onto the review service. Let's go and control that now. I'm going to clear existing rules. I don't have any as of now. So what I'm going to do is create a rule such that we always go to the version 1 of everything. Okay. So we always go to the version 1 of reviews, version 1 of product page. This is how the rule looks like. It's pretty simple rule. So you can see if the destination is reviews, with a precedence of 1, always go to version 1 of the reviews microservice. As simple as that. When you have this YML file or JSON file, you can see if I do refresh, it always goes to version 1. It will not go to version 2 or version 3. This is because we controlled it from the Istio control plane without having to go to any of these services and change code or change individual configurations. We just control all these things from a Istio control plane just by applying this simple rule. Okay, so that's the first step. So you can only see the version 1 of the application. But what I want to do is only for a user called Jason, I want to route to version 2, which is basically the black stars, right? This is important when you want to introduce newer versions of your application, and then you don't want to break everything. Even though it is in production, you want to do some testing before you actually make it live, right? Or maybe features like, let's say, you want to introduce a service in the East Coast, maybe in New York, and then test there for some time, and then make it available for everyone once once you're comfortable with that. So all these canary deployments, which are specific to very detailed, specifically like header-based canary deployments, all these can be done pretty easily with Istio without having to write a single line of code again into your application itself. So how is it done? If you look at the rule, that is your reviews test to v2 rule, this is how it looks like. If the destination is reviews microservice and the header contains a cookie with value user equal to JSON, then always route to version 2 of our application, of the reviews application, okay? Now, if for all other users who are not JSON, the application traffic will be same. But if I log in as a user called Jason, then I should see version 2. So you can see I only see version 2 if I log in as Jason. This can be, again, user-based or location-based, a lot of customizations you can do, right? It's pretty powerful. You didn't write a single line of code for this. You just have the XYML specification, that's it. Now what I want to do is, let's say for all other users, I want to split the traffic between version 1 and version 3, 50-50%. Okay, how does that look like? I just need to say route rule and then label version 1 and version 3 and then 50-50% weight, right? And that will make my canary deployment based on percentage of traffic. So if for the JSON user, it will be same thing. But if I sign out for all other users, you can see that it will be a split between version 1 and then version 3, which is either no stars or red stars. Okay, very simple. I didn't do any, again, a lot of customizations. I just controlled it from the Istio control plane. Right, so again, if you look at this, it is going very good, right? Now, what we want to see is we are okay with the version 3 version of our application, and then we want to route everything to version 3. So the rule, again, is simple. It just says if the destination is reviews, just send 100% of traffic to version 3 of our application. That's it. Okay. Now, if I do a refresh, it will always version 3. Okay. So you can slowly introduce your newer versions of microservices into the existing production stack without having to break anything. This is pretty useful for day-to operations. And then, and sometimes you want to, when you're developing microservices, it is also important for testing the microservices before they actually go live. You want to see the impact of one microservice on another microservices. How do you do that? This is important, like when you want to do some, let's say, dependency testing. How is the microservices dependent on each other? Okay, so for that, what I want to do is to do a simple testing. I want to introduce a fault on one of the microservices and then see how the other microservices are behaving. So in this case, I've just get rid of all the existing rules, and then I'm just applying a rule to go to version 1 of our application. This is what it says. And then what I want to do is, for a specific user, I don't want to do this for every user, right? I just want to introduce this slowly, and then maybe for a specific user, I want to do this fault injection testing. So for a user called Jason, I want to route out always to version 2 of the reviews service. So that is nothing but version 2 is this black microservice. Okay, and then let's take a look how it looks like. It is simple. We have already seen it. If the destination is reviews and the header value contains this cookie, always route to version 2, which is pretty easy to understand. If I log in as JSON, then I should always see black starts my review service. We haven't injected any fault yet. We are going to do it now. So what I want to do is, if the user is JSON, I want to introduce a 7-second delay on the ratings microservice, so which is here. So my user JSON is always going to version 2, but this review service is calling ratings. But I want to introduce a delay at this rating service and see how the application is behaving then when there is a delay on the rating service. Okay, so I've introduced a 7-second delay on this. The delay injection again is a simple YAML specification. You can see that all I need to say is I put this section, which is HTTP fault. Put a fixed delay of 7 seconds for all the 100% of requests if the header contains a cookie with value user equal to JSON, and if the destination is ratings. Okay, pretty simple logic. And then once you apply that, if I go and refresh this, you can see there is a delay. It is still loading. So it is because we have injected the delay into the ratings microservice. And you can see when there is a delay in the rating service, our application is broken. Okay, so from this, what you understood is without having to impact all the users, you can literally test in the production environment like how the application is behaving when one of the microservices is behaving improperly. So you can take an action like, oh, okay, I want to do some retry, or maybe scale my ratings microservices up, right? So all these things you can identify before you actually fail in production. This is pretty important in microservices adoption because you want to do a lot of testing before you introduce your newer versions. Okay, so we are able to identify issues before they occur. Okay. Now, let's say I want to introduce some timeout because we can also, let's say we will try something. If that doesn't come up in some time, we're just gonna give up and then show a user-friendly message. Okay, that is important if you wanna not bloat your microservices infrastructure with too many request calls. Okay, we will look into two things. One is timeouts, and the another piece is rate limiting. I will look both of them. Okay. So I'm clearing this out. What I want to do is I will again go back with the original step where I will forward everything to version 1. And then I want to introduce a delay on one of the microservices and then provide a timeout. So you can see that in live. Okay. So what this has done is, what this rule has done is basically if the destination is reviews microservice, always go to version 2. Okay, that's like we have overridden that rule, the first rule. The destination is reviews, always go to version 2 of the reviews. And I want to add a 5-second delay on the rating service, which is this service. I want to add a 5-second delay here. Okay, so the request path is like this now. Product page will call reviews and the reviews will call ratings, but there is a delay of 5 seconds here. But what I want to do is, because this is giving a 5-second delay, I will try maybe for 2 seconds or 3 seconds, and then I give up. Okay. The way how would I achieve this is basically just these 3 lines. That's it. So have a HTTP request timeout, which is for 2 seconds. So even if your book fails for after 5 seconds, the request will give up on after 2 seconds. Okay, it's pretty easy to understand as well. So let's take a look. So if you can see, now the application itself will time out in less than 5 seconds. Okay, you can see that happening now. So 1, 2, 3. It happened in 3 seconds, not 5 seconds. Okay, So that's the reason you can have a timeout on your request so that you will not like overload your systems with too many requests in the first place. So it's very useful for microservice architecture. I see some questions. Let me take if it is possible. Okay, I still see yes. All right, let's go ahead and then I'll take questions at the end. So we have seen applying timeouts in the microservices area. Now let's look at some of the rate limiting. Okay, uh, the rate limitings are pretty useful if you wanna, let's say, avoid some DDoS attack, or maybe you want to avoid overloading your systems with too many requests. That is pretty important if you want to keep all the microservices healthy. And let's say maybe some services are pretty premium services. You want to limit how many calls you make to that service. Okay, all this can be done using rate limiting. Again, applying rate limits is pretty simple uh, on a microservices. In this case, what we want to do is we want to uh, apply a rate limit on the ratings microservices. So let's say this is our premium service. Ratings is maybe like Zomato or some other external service, which is a premium service, and you want to limit how many requests you make to it per second. Okay. So the way you do it is you say if the destination is ratings, and if the request is coming from reviews version 2 service only, okay, you can control what is the source also. This is optional, but if you want to control only this flow, like only if the request comes from version 2, then I will do a rate limiting. For version 1 and version 3, I don't want to do any rate limiting. You can do that as well. Okay, it's very in detail, so very easy to understand as well. So the validity duration is 1 second, and then maximum I want to allow only one request per second. Okay, so what this means is if you make more than one call per second to this rating service from the reviews microservices, then it is gonna like stop it. Okay, so let's take a look how we are doing it. um, So what we are doing now is basically, this is a quota handler. We can ignore that. That's not required here. So let's log into our version 2 of our reviews microservice and then make a call to ratings microservice. Okay, we'll try to keep calling the rating services from these my microservices. So I will log into now the version 2 of reviews microservices and then make a call pretty fast. Okay. Now you can see I'm making a call every 0.5 seconds, like every half second I'm making a call. And then each of my subsequent call is getting a message called too many requests. That is with error code 8. That means I have rate limited this request to only one request per second. If you make more than that, then you are rate limited. Okay. So you can see that it's pretty simple, using a pretty simple YML file, I'm able to rate limit this microservice itself. Okay. All right. So this is all I have on the implementation side. There are a lot more. I'm gonna try to keep the docs up to date on this example. Have one more shopping cart example coming up, but I'll try to add more videos on this concept. There's one more final one, which is basically looking at the Zipkin tracings. Uh, Dan, do we have time for that, or we can take questions?
For you, we always have time, but how about if we just pause for a minute?
Okay.
And Kareem has been doing a wonderful job answering questions in the chat, and maybe if he wants to unmute himself and add anything in here. But Jonathan has one question around performance testing. We're wondering if you've done any performance testing with Istio installed, and if what the overhead is for using Istio. And I think that's a
Yeah, so Istio itself is like in very alpha stage, or I mean, it's not yet ready with these metrics. So these metrics needs to yet come out. I haven't done any performance testing, but this Envoy is a production-ready proxy, which is basically used in, I think, a very large organizations like Lyft and then bunch of other organizations. So Envoy itself is very much production-ready. The Istio control plane, along with the Envoy, is something we need to test yet. Okay, it's not yet like the metrics are not out yet.
Cool. I'm going to unmute Kareem just because I can type in the background if he wants to add anything in. And there's one more question, and I know this is one of those crystal ball ones, but when will Istio be supported in OpenShift? And I should never ask him when someone's asking around 3.8. What's your thoughts on that? I know you can't commit to anything.
So I mean, the support from Red Hat, I'm not really sure. Maybe Diajni has some insight into that, but the deployment perspective, 3.7 is what you need to look at. So if you want to try it out, then try the 3.7 alpha version of OpenShift. That's where I'm running it. If it won't work on 3.6 because there is a change in the custom resource definitions naming, that's why it won't work on any other versions. So the least version is 3.7. But whether it is supported or not is something out of my scope.
And as I mentioned, and in the chat, that Kareem has written a very nice blog post as well on evaluating Istio. That's on blog.openshift.com as of yesterday, I believe. So I think that's also another reference point for you. And you had also said that you were doing some work on the documentation for Istio around OpenShift. If I remember correct, is that hanging out around somewhere?
Yeah, so some docs, especially related to OpenShift, so I've added few steps like what exactly you need to do at the OpenShift specific commands like these. I've added those. So
awesome.
Yeah.
Thank you.
If you have any issues running Istio on OpenShift like 3.7, you can contact me. I will try to get more details on that. But what I observe is it needs some kind of privileged pods and then also SLNX disabled as of now. We have raised issues with that and then working with, there is a work going on. But assume that these things are not yet production grade yet. Okay, so things are still getting sorted out.
So if you're interested in contributing to Istio, the Istio website is up there. I think it's istio.io or something. What was that site again? Can you go pop back onto it, what the URL is?
Yeah, this is istio.io, and there is a Slack also for istio.io. They are pretty responsive. I always found answers from them on the Slack.
Yeah, they've been great. And it is really an up and coming project, I think, in the cloud native space. So stay tuned. I think there'll be a lot of work around that. I think we might save your last demo unless somebody says.
Any other questions?
I think that's a good time to end.
All right. Thanks, Diane.